Okay, this is a recap of test number 1. This is meant for those people that are going to be attempting to retake the test. So if you're going to be retaking the test, what you should do is watch this video, follow along, please, on your own paper. Don't just watch it and stare. You're not going to get anything from it. Follow along on your own paper, and then you will be able to take the test on Thursday. So once again, this is for those people that are going to be attempting to take the test. Make sure you follow along and do all of the 18 problems on this review that I'm going to do. Okay, let's get started. Okay, number 1 is pretty simple. It says solve the equation 3y minus 13 equals 5. Your first goal when you're solving an equation is to identify the variable, which I see it's y, and you need to isolate it by itself, meaning leaving it by itself on either the left side or the right side, doesn't matter. It's already on the left side, so I'm going to leave it there. The first thing I'm going to do is to get rid of the 13. Right? So you want to get rid of the 3 and you want to get rid of the 13. We're going to get rid of the 13 first by adding it. See how it says minus 13? The opposite is plus 13. So we're going to add 13 on both sides. That's going to cancel there. That's going to leave me with 3y on the left side. On the right side is 18. And finally, here's my y, right? You want to isolate the y. You want to get rid of the 3. What you need to do is do the inverse operation here, the opposite, right? This is multiplying 3 times y. The inverse of that is to divide, right? That is going to cancel. So we need to divide by 3, and that will cancel it out. You got to divide on that side too. So that leaves you with y equals 18 divided by 3 is 6. Done. That's how simple those are. Okay, number 2, same thing. I need to solve the equation. That means isolate the x. So there's my equal sign. That means on the left side, on the right side, I don't mix them up, right? I simplify everything on the left, I simplify everything on the right, and then I bring the variables together. So what I'm going to do first is to distribute the negative 9. Do not do 7x minus 9. You can't do that because they're not like terms anyway, okay? And even if they were, you would not do this first. You have to distribute first, right? That's multiplication. That's always before addition or subtraction. So we're going to distribute the negative 9. This negative 9, and make sure you include the negative sign if it's negative. If it's positive, then you multiply it positive. But that negative is included when you distribute. Times x and then times 3. You're going to leave the 7x, right? That one doesn't change. But then you multiply here. Negative 9 times x is negative 9x. And negative 9 times 3 is negative 27. On the right side is just 1. That hasn't changed. Next, you're going to bring together the like terms. If you look here, you have 7x and negative 9x. Those two get together, these two right here, 7x minus 9x, because they both have x. 7 minus 9, make sure you check your signs. You have a positive 7 and a positive 7 and a negative 9. That's going to give you negative 2. Negative 2x minus 27 equals 1. And you do not change it into x squared, right? It's just x. Next, we're going to kick out the 27 and the 2. The negative 27 and the negative 2. Both of those are going to go away. To get rid of the negative 27, we're going to do the opposite, which is adding at 27. That cancels, leaving you with negative 2x equals 28. And then finally divide by negative 2. To get rid of the negative 2, you need to divide. So divide by negative 2, divide by negative 2, and x equals negative 14. There you go. That is your final answer. Okay, here we go. Number 3, 1/4 times 8x minus 12 equals 15. By the way, I didn't mention this at the beginning, but what you guys should be doing when you guys are doing this is writing down each problem in your own paper so you can follow along. So go ahead and pause the video every time I start a new one so you guys have time to write it down and then follow me along, or try it on your own first. That's actually better if you try it on your own and then unpause it to come and see the correct way. Okay, so here we go. 1/4 times the quantity 8x minus 12 equals 15. First thing I'm going to do is distribute the 1/4 times both of them. Okay, so 1/4 times 8x. Actually, since I'm going to be multiplying, right, this is multiplying 1/4 times that, 1/4 times that. I'm going to make both of these fractions by putting a 1 under them. It's going to make it a little easier for me to figure out what the answer is if I make them both fractions, because when I multiply, I know that it's numerator times numerator, denominator times denominator, right? Numerator times numerator, denominator times denominator. So what I'm going to do is 1 times 8x for that first one. This is what you're doing right there. 1 times 8x is 8x. And 4 times 1 is 4. So over 4. See that you multiply the numerator times the numerator, the denominator times the denominator. In the next one, it's 1 times 12 is 12. And 4 times 1 is 4. Equals 15. Now I'm going to simplify the left side. I notice that 8 divided by 4 is just 2, so that's just 2x. And also 12 divided by 4 is just 3, so that's minus 3, equals 15. We're going to kick out the 3 by adding it, leaving you with 18. 2x equals 18. Divide by 2, and so x equals 9. There you go. 18 divided by 2 is 9. That's your final answer. The main thing in this one was the distributing. So make this a fraction so that you can distribute easily. And remember, numerator times numerator, denominator times denominator, right? 1 times 8, 4 times 1. And then you simplify them down to solve. Right, number 4 says convert $340 US dollars to euro. Use the conversion rate of 1 US dollar equals 0.89 euro. Okay, so I'm going to start by trying to figure out what it is that I need to solve for. I need to start with dollars and convert to euros, right? So I'm going to start with X euro. That's what I know. I don't know how many euros I have. It's called X. Okay. But I do know that I started with $340. So what you need to do in these problems is set up a proportion that tells you what the conversion rate between the two numbers is. If you're starting with euro and you're converting to dollars, here you should have the conversion rate for euro and dollars. According to what they gave me, $1 is 0.89 euro. Euro goes on the numerator, dollars goes on the denominator. So what I'm going to write on the right side is 0.89 euro and $1. There you go. So now notice what I did. I figured out what I need to find and put it over what I know. I know I have $340. I need to figure out how many euro, how much. In the right side, I put the conversion rate that they gave me. $1.89 euro. Making sure that euro goes with euro, dollars go with dollars. Do not mix them up. And now we're just going to solve by simply cross multiplying. So on the first one I'm going to do is x times 1, which is just x. And the other one is 340 times 0.89. Right? 340 times 0.89. And at this point is where you can use your calculator to make that multiplication. And my calculator says it's, oops, it's not dollars, it's euro, right? Let's cross that out. It's 302.60 euro. And that's your final answer. That answer makes sense because you have $1 is 0.89 euro. So the number of euros should always be less than the number of dollars. So if you have $340, your number should get smaller, 302. Okay, number 5. It says Glenn and Brian are two great runners. One day they challenged each other to a foot race. Glenn ran 1,400 feet in 2 minutes and Brian ran 2,100 feet in 3 minutes. Who ran the fastest? Explain. So we're comparing two runners, Glenn. I'm going to start by writing Glenn here. Glenn, who is 1,400 feet in 2 minutes. And Brian, who runs 2,100 feet in 3 minutes. The question is, who ran the fastest? I'm going to start with Glenn. 1,400 feet in 2 minutes. I need to simplify that for the unit rate. Okay, remember unit rate is when the denominator is 1. I want to make that as simple as possible. So 1400 divided by 2 is 700. He's running 700 feet per minute. That is Glenn. Brian is 2100 feet in 3 minutes. Simplify that down, unit rate, so divide it, 2100 divided by 3, you should get 700 feet per minute. So in this example, who's going faster? Who's running the fastest? Neither one. They are the same, 700 feet per minute. So what we're going to say as our answer is they run at the same speed. They ran at the same speed. They ran at the same speed, 700 each. Okay, number 6. A building casts a 110-foot shadow. At the same time, a 25-foot flagpole casts a 15-foot shadow. How tall is the building? Round your answer to the nearest foot. So the question is, how tall is the building, right? That's the question. So we're going to say X is how tall the building is. X is the height of the building. So that's going to help us identify what it is that we're looking for. So we got to know what X is before we solve it. X is the height of the building. So what I'm going to start with is by saying, comparing X, the height of the building, to, now you have two options. You could say the height of the building to the shadow of the building, height over shadow, or you could say height of the building over height of the flagpole. Either way, but it has to be something that is related to the building, to the height of the building. So it's either height over height, height of building, height of flagpole, or height of building, shadow of building, right? They have to be related. The only one that I cannot put here is the shadow of the flagpole, because it has nothing to do with the height of the building, right? So this is height of building. Underneath it, I could put the other height, which is the height of the flagpole, or I can put the other part of the building, which is the shadow, right? The other number that they gave me for the building. I cannot put the shadow of the flagpole. It wouldn't make sense. I'm going to go ahead and write 110, which is the shadow of the building, right? So this is the height of the building. This is the shadow of the building. So on the other side, notice what I did. Height over shadow. Height of building, shadow of building. I need to do height over shadow on this side as well, but this time the flagpole. Height of the flagpole, 25, over shadow of flagpole, 15. And then I can solve that. Solve by cross multiplying and you're done. Okay, before I finish it, I want to show you guys what the other form would look like. What if somebody instead chose to say height of the building over shadow of the building? What's the shadow of the building? 110. Oh, I already did that. Height of the building over height of the flagpole, which is 25. That's also allowed. You could do that. This is the height of the building, the height of the flagpole. Both are heights, so I can put them together. Over here, what I did is the height of the building and the shadow of the building. Both are about the building, so I can put them together, right? It works out that way. Now, on this side, since I have height of building, height of flagpole, what I should do here is shadow of building, shadow of flagpole. So, shadow of building, which is 110. Shadow of flagpole, which is 15. Now these equations, these proportions here look different, but they both will give me the same answer. Look, it's going to be x times 15, 15x, equals 110 times 25. Punch that into your calculator. 110 times, well, first I'm going to write it down, and then we'll do it on the calculator. 110 times 25. If you guys look at the one over there in black, x times 15 is 15x. And the other way is 25 times 110. 25 times 110. They're going to give you the same answer. Either way that you do it, they're going to give you the same answer. So I'm going to do right now is go ahead and punch into my calculator 110 times 25, which my calculator says is 2750. So 15x equals 2750. I'm only going to solve it on the left side because they're both going to give me the same answer. And then I'm going to divide by 15 to finish it. Divide by 15. And so x equals 2750 divided by 15. Again, I'm going to punch that into my calculator. And so my calculator says that x equals 183.333 repeated. So just 0.3 repeating decimal. And that is your final answer. This answer makes sense. Look, it said, according to the information, that the flagpole is 25 and its shadow is 15. So the shadow is shorter than the flagpole, smaller than the flagpole. That makes sense. The building is 183 feet tall. Its shadow is 110. That makes sense. The building should be taller than how long its shadow is. Okay, number 7. Ricardo was shopping for a pair of Nike basketball shoes at the mall. He found a really nice pair of shoes for $79. What is the total price of the shoes plus 9.1% sales tax? Round your answer to the nearest whole dollar. Okay, so what I'm going to do first here is set up an expression that represents the total cost of the shoes after sales tax. So I'm going to say P is the price of the shoes. Okay, so I'm going to say P is the price of the shoes. That's what my variable is going to be. P is price of shoes, of a pair of shoes. So if I want to know the total cost of the shoes after sales tax, what I need to do is add P plus the sales tax, which is 9.1%, change that to decimal form. This is a percentage. Decimal form means move the decimal over twice. So it's 0.091p. Right? Remember what we did? When you find the tax, you're multiplying it times the price of the shoes. So it's the price of the shoes plus the tax times the price of the shoes. That's going to calculate how much taxes it is. And now we do know what the price of the shoes is, 79. So plug in 79 for P. And so it's 79 plus 0.091 times 79, which is 79 plus, and then go ahead and do that part in your calculator to figure out what the price is. My calculator says that 0.091 times 79 is 7.189. So I'm going to add those two together to get the total price, which is going to be $86. And I'm going to round it, well, it's 189, right? 86,189. But it does say round your answer to the nearest whole dollar. So that's going to be 86. That's the cost of the shoes after sales tax. Okay, number 8. Each member in the Arroyo Marching Band needs to raise $700 as part of a fundraiser. Gabriel, the band's drum major, has raised $315 so far. Write an equation that models the situation. Okay, so it doesn't ask you to solve it, it's just to write an equation that models the situation. First thing you gotta do when they ask you something like that is figure out what the unknown is. What is it that we do not know about the situation? We know how much he's expected to raise, 700. We know how much he has raised so far, 315. So what's missing? You should be able to see that what's missing is how much he still needs to raise to get to the 700. We know what the goal is. We know how much he has raised. So the question is, how much does he have to raise still? We're going to call that X. X is amount he has to raise still. Amount to raise. Let's fix that. Raise. So I'm going to use that to write an equation. If I know what the amount he still needs to raise, and I add it to what, it gives me what? If I know the amount he has to raise still, and I add it to 315, which is what he has already raised, it should give me the total, which is 700. That's one equation for this situation. The amount he has to raise plus 315 should give you 700. There's another equation you could write. You could write, we know how much he has, we know how much he needs to raise, we are trying to figure out how much he needs to raise, and we know how much total he needs, 700. It's the same equation, but it also works for this situation. There should be others. You should be thinking of other ways to write this equation. For example, we could start an equation that starts with 700 and says, if I know how much I need to raise, 700, and I subtract what I have already raised, 315, it should give me what I need to raise, x. Isn't that equation the same idea as the other ones that we already did? And we could also say, well, if I know how much I need to raise, 700, and I subtract what I need to raise, then that gives me what I have already raised, 315. This is going to be a multiple choice question on your test, so look for any of these that make sense to the situation, right? On your multiple choice, it might be this one, it might be this one, it might be this one, it might be this one. All of these make sense in this situation. Okay, number 9. The perimeter of a rectangle is 64 meters. The width of the rectangle is 4 meters less than its length. Find the length and the width of the rectangle. Okay, so first here I have a rectangle here. I'm going to label it L for length. Here's the length. This is also the length. And these are W and W. I know that the perimeter of a rectangle means add up all the sides. So it's W plus W, two of them, plus L, which you could write much easier as W plus W is 2W, and L plus L is 2L. That's the formula for the perimeter of a rectangle. We're going to use that to try to solve. Next, I need to read the problem and figure out what they told me. They told me that the perimeter is 64, so I'm going to write that down. P equals 64. That's going to help me a lot. What I'm going to do with that 64 is I'm going to plug it in right here, because P is 64. Then it says that the width of the rectangle is 4 meters less than its length. The width of the rectangle is 4 meters less than its length. Notice how it's comparing width to length. See that? And we practice doing this when we're trying to figure out what the variables are. It's comparing width to length. Which one is mentioned first? Width, right? The one that is mentioned last is length. So what you need to do, set up L and W and figure out which one is going to be the variable, which one is going to be the X, okay? And like I said when we were practicing these, you look at the sentence that they gave you. The width of the rectangle is 4 meters less than its length. The first one mentioned is not X. It's not the variable. It's always going to be the last one mentioned, which is length. L is your variable, which is length, right? We're just going to call it L. For the width, you read the sentence and you try to figure out how can I interpret the width using the L that I already have. The width of the rectangle is, 4 meters less than the length. Less than means minus, but it's not 4 minus L. Remember, less than is the one that you flip around. It's the reverse, so it's L minus 4. You're going to write L minus 4 for the width. So the length is just L, but the width is L minus 4 because it's 4 less than the length. Using those two, I'm going to take those. I'm going to take P also, using that one. So using P64, put it right there. W is L minus 4, put it right there. And L is just L, so leave it alone. We're going to solve this equation, okay, like this. Where I see P, I'm going to put 64. So it's 64. 64 equals 2 times, instead of W, I'm going to plug in L minus 4. And plus 2L. L is just L, so I'm just going to write 2L. And that's going to help me solve the equation. 64 equals, distribute the 2L minus 8 plus 2L. I'm going to combine like terms, which is the 2L and the other 2L. That's 4L. So 64 equals 4L minus 8. And I'm going to solve for L by adding 8 and dividing by 4. So first add 8. Add 8. 64 plus 8 is 72 equals 4L. Divide by 4. Divide by 4. And there you go. L equals 72 over 4. According to my calculator, it's 18. That's the length of the triangle. Let's see if we answer the question. It says find the length and the width of the rectangle. So L is 18 meters. And width, according to the information over here, width is whatever the length is minus 4. So if the length is 18, the width is 18 minus 4, which is 14. And there you go. That's your length and your width. Okay, number 10, solve V equals 1/2 BH for H. I need to solve for H. That means isolate DH. First thing I need to focus on is where the H is, right there. That means that I need to get rid of B, and I also need to get rid of 1/2. I'm going to get rid of 1/2 first by multiplying times the reciprocal of 1/2, which is just 2. So I'm going to multiply both sides by 2. Times 2, and this one times 2. That's going to leave you with 2V on the left side. On the right side, what happens is this 2 cancels that 1/2. They cancel each other out because they're reciprocals of each other. So 2 and 1/2 cancel out, leaving you with just BH. And finally, since we want to solve for H, that means we need to get rid of B. We're going to divide both sides by B. Divide both sides by B, and there you go. H equals 2V over B. Done. Number 11. David has no more than $90 to spend on a $15 shirt for himself and 3 gifts for his friend. Okay, first I want to focus on what it says right here. No more than $90. That means he can't go over $90, right? And he's going to spend on a $15 shirt for himself and 3 gifts for his friends. How much can he spend on each gift if he buys the same gift for each friend? Use G to represent the cost of each gift. So G is how much each gift is. He's buying 3 of them, so total that's 3G. That should make sense to you guys. If they want G to represent the cost of the gift, and there are 3 of them, it should be 3G. But he's not just buying the 3 gifts, he's also buying a $15 shirt for himself. And his total cannot go over 90. Right? So I'm going to put 90 here. And I need to figure out which inequality symbol. It's not equal to 90. We don't want him to spend exactly 90. He can spend 90 or less, right? He cannot go over 90. So my inequality symbol here should be less than or equal to. He can spend exactly 90 or he can spend less than 90, but he cannot go over. And that's the inequality that we're going to solve. Let's solve it first by subtracting 15 to both sides. Minus 15 minus 15. 3G is less than or equal to 90 minus 15 is 675. Divide by 3. Divide by 3. And G is less than or equal to 15. So that means that David cannot go over $15 per gift. He can spend $15 on each present, on each gift for each friend. Okay, number 12, solve the inequality, simplify if possible. Negative 3 times x plus 5 is greater than or equal to 4x plus 13. I'm going to start this one by distributing, like we usually do. So I'm going to separate the left and the right. And I'm going to distribute the negative 3. I see parentheses, I think distribute right away. So I'm going to multiply that one times that one, and then that one times that one. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Greater than or equal to. On the right side, you have 4x plus 13. So we're going to solve that, and we're going to put together the 3x and the 4x. Next, what I want to do is put the negative 3x and the 4x together. Bring them together to the same side. you have options here. You could either add 3x to bring it over, or you can subtract 4x to bring it over there. It doesn't really matter which way you go, just make sure you're being consistent and you're following the correct steps. So if I wanted to move this one, I would add 3x. If I wanted to move this one, I would subtract 4x. Okay, I am going to add 3x to both sides. I always prefer to add than to subtract. So I'm going to add 3x to both sides. That cancels. On the left side, I have negative 15. On the right side, I have 7x plus 13. And now at this point, it's just a two-step equation. Get rid of the 13, get rid of the 7. So minus 13 on both sides. And you get 7x. Negative 15 and negative 13 make negative 28. And then divide by 7 on both sides. And so x is greater than or equal to negative 4. I mean, x is less than or equal to negative 4. Now, you can leave it like that. If you'd rather see the x on the left side, which a lot of you guys prefer, go ahead and switch the x and the negative 4. But if you do that, if you switch sides, you also must flip the inequality symbol. So instead of going to the right, it's now pointing to the left. And those two mean the exact same thing. If you look at them, they mean the exact same thing. This one is saying that negative 4 is a number that is greater than x. This one is saying that x is a number that is smaller than negative 4. Both are saying the exact same thing. Okay, 13. Solve and graph the compound inequality negative 4 is less than or equal to x plus 3 is less than 13. What you need to do here is solve two inequalities at the same time. Your goal is to leave the x in the middle by itself. So really all you got to do in this one is kick out the 3 by subtracting it. We're going to subtract 3 from both sides. So that means that in the middle all I have left is x. On the right side, 13 minus 3 is 10. On the left side, negative 4 minus 3 is negative 7. The inequality symbols that were there to begin with, less than or equal to, and less than, stay there. That's it. That's your final answer. Now it does say solve and graph, so we're going to graph this. This is what we call an AND inequality. I know because it looks like there's an x in between two other numbers. Okay, that always represents an AND inequality. So I'm going to graph it. And the easy way to graph this is to just make a number line. Find the two numbers that you're looking for, basically your limits, which is negative 7 and 10. So negative 7 on the left, 10 on the right, right? There's a bunch of numbers in between them, but they're not important to this situation, right? All we care about is those two. Next, you're going to draw two circles, one on the negative 7, one on the 10. You're going to choose if this circle is supposed to be open or closed for each one. This one, less than or equal to, that's closed. That means you shade it in. For this one, less than, that's open. So leave it open like that. And then since it's an AND inequality, you're going to shade in between. So some of you guys shade like this. Some of you guys shade like that. It's the same thing. The point is that you're shading between the two numbers. Okay, number 14. Write the compound inequality shown by the graph. So 0, 1, 2, 3, and 4, 5, 6. What I'm looking at is that what number it's starting at. Before I actually do that, let's identify if this is supposed to be an AND inequality or an OR inequality. If you notice, it starts at these 2 points and it's going in opposite directions. That represents an OR inequality. This is an OR. So for OR inequalities, we have to write the word OR every time. Then look at the left part of the graph and determine what is that point. If this is 5, then this is 4, then this is 3. This is 3 right here. So you're going to write x and 3. The question is, what is this representing? Is it representing all the numbers that are less than 3 or all the numbers that are greater than 3? And you see that it's going to the left, so it's all the numbers that are less than 3. So you're going to draw a less than symbol. And before you finish and say that's it, check, is this shaded or, open or closed? It's open, so you leave it like this. If it was closed, I would put an equal sign below it. Okay, that's it for the left side. You put the word OR in between, and now you do the same thing for the right side. On the right side, it looks like it's starting at 6. This is 5, this is 6. So you're going to write x 6. Check if is this representing all the numbers that are greater than 6 or all the numbers that are less than 6? You can see it's all the numbers that are greater than 6. So we're going to use a greater than sign. And last thing, check if it's open or closed. This one is closed, so we're going to put an equal sign right there. And that is the compound inequality. There is no short form of writing these inequalities. If it's an or inequality, we have to write the word or in between the two inequalities. 15. Daniel is driving on the freeway and sets his cruise control at 60 miles per hour. The speedometer must be within 2 miles per hour of his initial setting. Well, first of all, this is a run-on sentence. Period. The speedometer must be within 2 miles per hour of his initial setting. Draw a graph that represents Daniel's speed while driving. So if he sets it at 60 and the speedometer keeps it at 2 miles per hour within 2 miles per hour, that means that the speedometer is only going to kick in if it's 2 miles past 60 or 2 miles below 60. Okay, so 2 miles past 60 is 62. That's the highest it can go before it kicks in. And 2 miles before 60 is 58. That's the lowest it can go before it kicks in. By the way, it's not the speedometer. I just noticed that. What keeps your car going at the correct speed is the cruise control. Let's fix that. The speedometer only tells you how fast you're going. Cruise control is what keeps your car going at the same speed. So, again, since he sets it at 60 and it's within 2 miles, that means that it can go 2 miles above or 2 miles below. If we represent the speed that he wants to be at as x, x is somewhere between 58 and 62, including both. And now all you got to do is just make a number line and graph that. Here's 58. Here's 62. And x is somewhere in between. We're going to put an open circle here, open circle here. Before we check it, I always draw them open and then I check. Ooh, it's less than or equal to, less than or equal to. So both are actually supposed to be closed. Closed, closed. And then shade in between, like that. Or like this, same thing. There you go. That represents the speed on Daniel's car. It's somewhere between 58 and 62 at all times, as soon as he sets the cruise control. Alright, continuing. 16 and on our free response. Remember on the test, once you get to the free response section, show all your work if you really want to receive full credit. If you just write the answer there and don't show me the work, you are not going to get credit. Okay? Make sure you show all your work. And also, if you do get it wrong, but you did some work, I'm going to give you some credit. So try to do something on each one. So here we go, number 16. Y equals mx plus b. Solve y equals mx plus b for b. So that means I want to isolate b. Here's my equation. I want to isolate b. Here we go. If I want to isolate b, which is right here, I need to get rid of mx. And since this is being added right here, I can get rid of both of them at the same time by simply subtracting mx. And that all goes away. So on the right side, all I have is b. On the left side, it's y minus mx. Done. B is isolated, you're finished. Doesn't matter that b is on the right side, that's okay, you still solved it, you isolated it. Okay, let's go to part b then. Part b is the same equation, but it's asking you to solve for x instead of b. So instead of isolating the b, you need to isolate the x. The steps are almost the same, but this one takes 2 steps instead of just 1. First, you're going to kick out the b. Here's x. Don't kick out the m first. Kick out the b because it's the one that is farthest away. So we're going to subtract b. That cancels. On the left, you have y minus b equals mx. And then what you're going to do is you're going to divide both sides by the other one that you need to isolate, right? We're solving for x, so I need to get rid of m. We're going to divide by m. and you're going to divide the left side by m. Notice that I wrote an equation, a fraction bar over the entire thing, and then just put an m. That cancels, so it's x equals y minus b over m. Done. 17. Simplify the expression 2/3 minus 6 times 2 plus 3. A lot of you guys are still getting this wrong, and you should not be getting this problem wrong. This is order of operations, something that you guys did back in 5th and 6th and 7th and 8th grade. You should be able to do this, okay? So just make sure you're following the order of operations correctly. So for example, in this one, I have an exponent, a minus, a multiplying, and a plus. There's a lot of things to do. Which one is first? The exponent. We're going to do that one first. 2 to the 3rd power. It doesn't mean 2 times 3. So if you write 6, right away you're wrong. It means 2 times 2 times 2. 2 to the 3rd power means there are 3 2's. Multiply them all times each other. So it's 2 times 2 times 2, which is 8. Minus 6 times 2 plus 3. I didn't do anything else except for that, just to make sure that I'm doing the work correctly. Next, I check and see that I have a minus, a times, multiplication, and a plus. Which one should I do first? The multiplication. You do not subtract, you do not add until you multiply. 6 times 2 is 12. So it's 8 minus 12 plus 3. Now I have minus and plus. And a lot of you guys get this wrong because you choose to add first. Because you think, oh, it says PEMDAS or GEMDAS, which is the same thing. And you think adding is first and then subtracting. And that's not true. Adding and subtracting go together. So it doesn't mean that adding is first and then subtracting. It means that they're together, and whichever one you see first from left to right, that's the one that you do first. So in this case, don't add, subtract first, because that is the first one that I see, and they're both equally important. So 8 minus 12 is negative 4 plus 3. Now I can finish it, gives me negative 1. If someone had added first 12 plus 3 making 15, they got 8 minus 15, and now they got the entire thing incorrectly because they decided to add first. That's your final answer. Alright, this is the last one. 18. Joe and Fernando are collecting Pokemon to see who can collect the most. Joe has 50 Pokemon and is getting 2 more per day. Fernando has 30 Pokemon and is getting 4 more per day. Write an equation to model when Fernando and Joe would have the same number of Pokemon. Let X represent the number of days. So I need to write an equation to show when they would have the same number, when they would both be the same. Okay, so I need an equation to show that Fernando's number of Pokemon is equal to Joe's number of Pokemon. So looking at the information, it says that Fernando has 30 and is getting 4 more per day. So Fernando's expression is going to be 30 plus 4 per day, and we'll say X is the number of days. For Joe, Joe has 50 and is getting 2 more per day. So for Joe's expression is going to be 50 plus 2x, 2 more per day. That's it for part A. It says write an equation to model it. Done. Part B, solve the equation. Now we can solve it. 30 plus 4x equals 15 plus 2x. So 30 plus 4x equals 50 plus 2x. What I want to do is simplify the left side. There's nothing to combine. There's nothing to distribute. Done. Simplify the right side. There's nothing to distribute. There's nothing to combine. Done. Then I notice that there's x's on both sides, and that can't be. So either bring this one over here or bring this one over here. I'm going to subtract 2x to move it over. I'm going to get left on the left 30. Oops, 30 plus 2x, right? Because it's 4x minus 2x. On the right, just 50. And now it's a two-step equation. Get rid of the 30, get rid of the 2. First, I'm going to subtract 30 to get rid of it. Minus 30. So it's 2x equals 20. And I'm going to continue over here. 2x equals 20. I am going to divide by 2 to finish it. And so x equals 10. That's the solving of the equation. That means that after 10 days, they both will have the same number of Pokemon. C, how many does Joe have after 11 days? So what you do is go back to your original equation, look at Joe's expression, and plug in 11. So for Joe, it's going to be 50 plus 2 times 11, which is 50 plus 22, which is 72. 72 Pokemon for Joe after 11 days. D, who has the most in 11 days? That means I have to find how many Fernando will have in 11 days also. So for Fernando, it's 30 plus 4x. So 30 plus 4x, which is 11, which is 30 plus 44, which is 74. So Fernando has 74. So who has the most? Fernando. Fernando has 74. Joe only has 72. So Fernando wins in 11 days. Okay, that was the end of it. That was the last example, all 18 of them. Those are the problems that were on your test, and that will be similar problems on the retake that you guys will take. So, okay, make sure you guys watch the video, follow along with the problems, study, study, study. To prove to me that you actually went ahead and studied and you're ready for the retake, leave a comment on this video.